Hello everyone. It was just a little musical reminder that last tutorial, or actually not the screen movie tutorial, but the one before that, we made a really groovy MIDI keyboard, and that's what I was just playing. There it is. Hey, we'll get back to you later. Alright, so this tutorial we're going to focus on analog, not really, audio. What do I mean? Analog is waveform audio, and we're working on computers, and there isn't really anything waveform anymore except for maybe 2 inches of wire leading up to the speaker. Everything else is still waveform, but it's highly sampled. But we're still going to call it analog, and it's still going to be fun. So let's open a new patcher, bring it down here over the title so we don't have to look at it all the time. And let's start making an analog synthesizer. To do that, we're going to type N, we're going to type saw, and a tilde. A tilde is up in the upper left of your keyboard. You will probably have to hit your shift key, or you can come down here and just double click on the old saw, and you'll get a saw there. And as we like to do, this is an oscillator that makes a waveform that is the shape of a saw. And we'll see that in a minute, but right now I'm going to option click on it and get that help file. Come right up here, unlock my help file, grab that keyboard like you mean it, and, well, while we're here, well, no, we'll just copy it. You know, I'm not going to copy this thing over here. It just doesn't have the look that I like. I'm going to copy all this stuff. Okay, let's copy that. There we go. Command C, Control C if you're on a PC. Close your help window. Come down here, erase that, paste everything. There it is. And I'm going to zoom. No, I don't need to zoom. I'll zoom the other way. So, what have we got here? We'll take a look at it piece by piece. Well, I'm going to lock my patcher. This is our keyboard. And that's funny. Sorry. This is how you turn the audio on and off in Macs. We haven't dealt with that yet. And this is how we deal with volume. So obviously the one thing that this has is the ability to make noise, but not the ability to shut off the noise. Something to keep in mind. But here we go. Nice. And we'll just turn that down a little bit. So that's what this, as you can see, is making us, let's pick something in the middle, is what we call the saw blade shape. And it's that saw blade shape that gives it the distinctive sound that comes from that type of oscillator, that sort of analog oscillator in the past. This is now produced digitally, but it produces an analog waveform digitally that, okay, let's not speak of this anymore. Let's call it an analog wave. This is the saw blade pattern. Okay, well, moving forward, how are we going to create a synthesizer that can play this type of oscillator from a keyboard input? Well, the first thing we're going to do is kind of get rid of this input, and we're going to use our own keyboard from last week. I'm just going to, which I was playing earlier at the intro, and there it is, as you can see. And what we're going to do is, instead of having this go out the synthesizer, we're going to have it play out IAC driver bus 1, but I'm getting ahead of myself. Put that over there, and let's delete that, and hello. Hello. Okay, delete. So let's get a new object up here, N, and then just type note in. And a little, there it is, note in. Where did my mouse disappeared to? I have no, there it is. Hello, mouse. There is our note in, and I'm going to stretch it out a little bit there. So what note in is like MIDI in, but it only receives notes. So we don't have to go find the notes in the big MIDI message. Notes just come in here, okay? So we want the notes to come in, and we'll see that there's pitch. Here is velocity. And this is MIDI channel. Not particularly important for our purposes today. Okay, so once the notes come in, we are then going to have them go through another new object. So let's type N, we'll type poly, and we're going to type poly with no tilde. So make sure you do not type anything after it. Just hit a space and then say voices. Since we have our Bart Simpson three-fingered hands, we're going to go for the 6 voices. So let's type the letter 6 and then another space. And then there's another thing called here called steal mode. And all you have to do is type any integer and it puts it in steal mode. What steal mode means is if you actually push down 7 keys, the 7th key that you push down will just steal the voice from the first key that you push down. So you're never going to play more than 6 actual notes. Steal mode, if there's a 7th, it steals the first one, and so on and so forth. So I'm going to put a 1 there. And that's good for poly, but at least up until recently, the help file on poly was not terribly good. So once again, you benefit, to some small degree, from having an instructor. So I'm going to stretch this out a little bit. And we are going to connect note, pitch, to poly, pitch. And we are going to connect velocity to velocity on poly. And now we have to stop to consider what poly is. So as you may remember with the K slider and from very, very peculiar records from the old days. No, I'm kidding. Poly means polyphonic, which it means multiple voices. So the poly tool is to make multiple channels. So what we have down here is essentially one channel of an oscillator. This will only be able to make one note. No matter how hard we try this, I mean, it can make many different notes, but it can only make one at a time. So a polyphonic synthesizer, especially one with 6 voices, will be able to make 6 notes at any given time. Okay, that's what poly means. Now, how are we going to make this work for us? We're going to exploit this thing that poly does. This first outlet here on the left is voice number. So it's going to, when the notes come in, it's going to distribute them from 1 to 6. So there'll be voice numbers from 1 to 6. Then comes the pitch, and then comes the velocity. Actually, I don't want to confuse it, but they actually go in the other order. It goes bang, 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 and then it sends it. So what are we going to do here? We're going to get a new device out here to distribute those voice commands. So type N and then type spray. And spray is sort of the opposite of funneling. It takes it takes a single inlet and it distributes those to multiple outlets. How many outlets? Well, hit spacebar and then tell it 6. And then say, well, gosh, what is the offset? A number of times we've run into the problem of digital things starting to count at 0. It's almost madness. So what we have to do is offset 1 so that our first outlet, if Poly sends out voice 1, that it goes to outlet 1 instead of outlet 2 because outlet 1 is 0. Am I making this more confusing than it needs to be? Yes, I am. But if you put the offset at 1, the first outlet will be numbered 1, which is what you want, trust me. So 6, 1, and then one more thing. You see that last thing down there, list mode. If you enter any integer here except 0, it will put it in list mode, and we need it in list mode so that it can send pitch and velocity as a list. If it's not in list mode, that won't work. So type another 1 there, and our spray is ready to work, except for one thing, and I think you can probably already see the problem. Between Poly and spray, Poly has these 3 items that it's sending out, but spray only has 1 inlet. So we're going to need another device, and this is a device that we use quite a lot in Macs, and it is called the pack object. So P-A-C-K, and then just type 0. Well, first a space, then a 0, then a space, then a 0, then a space, then a 0. Okay, and that will be able to handle those 3 things. So now you see the pack is ready to accept 3 messages and pack them into 1 message. Okay, so we'll do that. We'll connect those 2 and connect those 2, and we'll connect this here, and then we are just going to have to check and see if all this crazy stuff is actually working, because it's almost hard to believe at this point. So I'm gonna pull everything downward here a little bit to give us some room, and I'm gonna make a couple messages by typing the letter M. And let's just set these up so that we can see this working. We're going to put this one up here and connect its right-hand inlet to the pack object. We're going to move this one over here and connect it to outlet number 1. Thank goodness for offset instead of it being outlet number 0, and outlet number 2 here. This is just for fun. Now we're going to go and get our fancy keyboard again. Hello, fancy keyboard. And turn the volume all the way up. And you notice we put this on IAC driver bus 1. I'm going to push this up here. If you double click on node in, oops, sorry, lock the patcher. If you double click on node in, you'll notice that it's right now it's letting in all devices by channel. So it would have worked, but let's set it to IAC bus 1, which is a virtual MIDI bus. And we'll set it to that. So now supposedly node in is listening for the output of this keyboard. And now we will just play something and see what happens, and we'll watch all these messages and interpret them. There is the low C, and it says 1, that's voice 1, note number 36, 127 velocity, because we turned the volume all the way up, remember? And look, outlet 1, that's what this 1 was for, came note 36 at 127. I'm going to let off the note, and it goes to 0. That's going to shut that note off. Now I'm going to press that, whoops, oh darn it, now I have to go all the way around again. You see what happened? It went to 236, I hit the same key again, and it came out outlet 2. So now we'll do this again. Now we have it going out outlet 3 and turning off. This one will go outlet 4 all the way over here, and it'll be note number 40 at 127, and then it'll turn off. This is going out outlet 5, it's note 41 at 127, and now it's turning off. Note 43 comes out outlet number 6 at 127, and then it turns off. And here we come back to this should start over at voice 1. So here we go. There it is. Go out voice 1, note number 45. There's note number 45 at 127, 127. Perfect. It is working perfectly. And just to play the devil's advocate, we'll turn the volume down a little bit and see what happens if we send the next note out with a lower volume. There it is, look. It's going to come out voice 2, it's going to be note number 47, and it's going to be an 81 velocity. And there it is, note number 47 at 81. So this keyboard is communicating perfectly with this, and if we can find a way to turn these messages into something that can trigger this note and turn this on and off, we will be set with our MIDI synthesizer. So I'm going to move my keyboard off to the side here, and we are just going to get started here. So the first thing that I'm going to unlock my patcher and just move this off to the side. The first thing that we have to do is split this message back up. And just like there's a pack object here, there is, type an N and just type unpack space 0 space 0. Okay, so this put those three messages together. This is going to take these two of them apart. So we connect that there, we connect that there. I'm going to move that out of the way. And now we say this one can come down here and go right to the MIDI, because we know that the pitch will tell the MIDI what to do. Now we have an interesting, I'm not going to say an interesting problem, but a challenge, that we want to be able to take any note that comes through here and have it turn the volume up to the right amount, including 0. So we could almost hook this directly to this gain, and it should, if it gets a high value coming in here, it'll turn that up, and then when it goes to 0, it'll shut it off. Let's see what happens, but we'll have to go around again. I'm going to lock my patcher, play my keyboard. There's 4, 5, 6. Here it comes. Ready? So at 81, it turns this thing right up there. And when I let off, what happens? It shuts off. Fantastic. So far, so good. We have the workings of a very, very simple synthesizer here. So let's make this, let's make a whole bunch of them and get this thing into its proper polyphonic self. So we can, I think, unlock our patcher. We can make this one here smaller. Whoop. Because we're not going to need to see a big one like that for every single one. And then we can put this over here. All right. Actually, this can come down here. All of the synthesizers can use the same, this is called an easy DAC. It's the audio out on Macs, but they all will need their own gain control in here. And I'm just going to get rid of these so that they're not taking up space. Same thing with these. We don't want them taking up space. But I would like to see this outside of the synthesizer. And you may or may not have realized what I'm about to do, which is I'm just going to take these things here, not that, these, and I am going to encapsulate them. So you can either go Shift Command E, or you can just hit encapsulate. And now it says it's P. Get in there, and after that P, push a space bar. Your name, Johnny. Your name's not Johnny. Don't put Johnny. Just don't do it. Okay? Analog. So now we have, I'm just going to get rid of these. They're also in my way. So now we have a patcher called Johnny Analog. We have this beautiful thing here. Looking great. And now we could just take this, drag over both of them, and let's go to town. Duplicate, 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 duplicate. All right. Is everybody having fun? I am. Okay. And we hook those back up. Now, be careful to notice that this thing had decided to have the oscilloscope come out the left side and the signal come out the right side. This is the signal that goes through the gain control. So you don't want to mess those up, or your note won't shut off. So make sure that you keep these the way they're supposed to be. Okay? So then you have to go connect these to here. You can also use the shift trick here, but it doesn't get you very far. Like I go here, but I hold shift and then I click, and then I click here, but I've let shift up. Are we all familiar with this now? Shift down, click on that, shift up, click on that. Shift down, and then I click on that, shift up, there it is. Okay, so now I'm gonna bring my keyboard back in here and play it. Don't know if you can hear that very well. It's funny, it's not stealing, but it's just limiting it to 6. I can only push down 6, and then it's like, nope, that's it. Wow, what a powerful sound that is. Well, that's super exciting, I have to say. But are we satisfied? No, of course not. We're not satisfied. Let's think about something here. If we have this saw blade shape in here, getting all sorts of things here. Let's just move this over here for a minute. Okay, so we have a saw blade shape, but there's other shapes that we could have too. So one of them, type N, is the sine wave, which is cycle, tilde, and there it is. Sinusoidal oscillator. That's what you want. Cycle tilde. Make sure it has a tilde. Okay. Now, do you need to put the 440 in there? No, you don't. Really, because this thing is going to be supplying a number for that. So there's one. And then could we have another oscillator? Of course we could. So how about the famous rectangle tilde the anti-aliased rectangular pulse oscillator. There it is. We'll put one of those in there and connect that up. There. But now we have a little bit of an issue because they're going to be putting out sound, but how do we decide what sound is going to come out? Well, we have a special tool for that called a selector. Tilde. In case you haven't caught on, the tilde is for when you're using, dare I say it, analog waveforms. And you'll also notice when you're using objects with a tilde, you get these fancy striped patch cords that are essentially saying, hey, we have waveform data running through us. Okay, so selector, and then hit the space. Number of inputs, 1, 2, 3. Okay, 3. And then initial open inlet. You don't have to put anything in there, but let's put 1 in there so there's always something that's open when the machine starts up. Okay? And then you'll notice, though, that we get 4 inlets on the top of selector, and that is because one of them is to decide which selector it is. So that'll take an integer to tell it which one to select, and then each one of these is for a different signal. Signal 1, signal 2, and signal 3. So here we go. There's signal 1, there's signal 2, there's signal 3. We want this outlet, which goes to the scope, that little thing that shows the waveform. We want that to go there, and we also want the signal that goes to the gain control to come out the bottom there. So now these are all making their signals, and depending on the selector, they'll come around and they'll go out there. Now we need to control them. We want to do that probably from outside of this little box. So I'm going to, I'm just going to copy this one because inlets are so easy to copy, and make another inlet there and put that just like that. And now we can close this Johnny Analog, and we see that we have another thing here. Let's make a new control for this. We're going to unlock this patcher, type N, and type radio group. And then, yeah, you know, this one's easier to do. You could, that's funny. I believe that the term is at size, and then we can type 3, but just don't type anything. Let's deal with it as it comes. Okay, it did exactly what I thought it was going to do. It only has 2 selections. So we're going to highlight it. We're going to come over here to the inspector. Come on, inspector. Come closer. And we're going to scroll down, and we see, whoop, my mouse keeps freezing. We see size. That's at size. So we could have put at size when we typed that. Number of items, 2. Just double highlight that and change it to 3 and hit return. And look at that. Our radio group now has 3 items. But radio group is one of those digital things that puts out a 0 in its first position. So we're going to, underneath it, type the letter N and write plus space 1. And that has to go in the left inlet, and this goes down here. There we go. Let's see how we did. I'm locking my patcher. There's 1. There's 2. The reason for this is that we have not yet fed any numbers in here. So as you may remember, the sinusoidal oscillator, known as cycle, and the rectilinear oscillator don't have any frequencies in them yet. So we'll just bang on some keys with our patcher locked so it doesn't... There we go. So now that's a sinusoidal wave that we see there, and let's go for 3 now. And there's the square wave. But, as you notice, none of these are doing that. And you know what that means. That means we've got to copy this and put it inside every one of those. Oh my goodness. No, we don't. We're geniuses. We don't have to do that. Here's what we're going to do. We're going to open this. And what we're going to do right now, I'm going to close it again. This is a sub-patcher. There's a little P there. Each one of these can be different inside, even if they have the same name as a sub-patcher. But we are going to turn it into a patcher in a patcher, which is completely different. It's the same, but it's completely different. So let's open this, and what we're going to do is copy everything, and then open a new patcher, and paste it in there, and then save it as, and if you haven't changed the name of your analog patcher yet to be something something that works for you, here we go. Max 9. Is this teaching patchers? I'm just trying to decide where to say. Now is the time to do it. But me, like if you're just using Johnny Analog, for example, and you shouldn't be, this is a good time for you to change the name. Okay, so I'm going to call this one Johnny Analog because I'm allowed to, because I'm Johnny. And I'm going to save it in my Max 9 folder there. And now it's saved, and I'm going to put it away. Now I'm going to do something really funny, and I'm going to close this one too. I'm going to come down here, and what we're going to do is change this from being a sub-patcher to being a standalone patcher. Right now with that P there, this patcher is contained inside the parent patcher here, but we click inside here and we delete that P, and look, Max already knows what's happening. It says Johnny Analog. I'm going to click on that, and there it is. All of a sudden, this is the Johnny Analog standalone patcher. Okay, so, and I can do that all the way across here. Johnny Analog. Now, the question is, does this do us any good? And, whoops, hey, I accidentally deleted the name, so I'm just going to type Johnny Analog. You know, there it is, another one. I don't know how I deleted that one. I must have been just going crazy. All right. So what's so great about these being standalone patchers is that you might not have noticed, but maybe you did, all of a sudden they all have the extra inlet over here. That's because they're all identical. Every one of these is going to be identical. If you change something in one of these and save it, every one of these will change. Now, the cool thing is that you remember whoops, let me lock my patcher before I open this, that we made this modification. We put these 3 things in this patcher, right? Now I'm going to go to the next one. Let's look at it. Hey, it's already got those 3. You see what I'm saying? Now, it doesn't have any, because it's brand new, as though it were just born, it doesn't have any frequencies or any numbers in it yet. So you have to keep that in mind, that when you do that, these reset to 0. But they're all, we'll go to the last one there, they all now have all 3 of them. So that means that if we connect these all thusly, I'm pushing the shift key down for speed and quick work here, letting it up here before I connect. There we go. Now I'm going to go back up to 1. I'm going to bring my keyboard in here again. I'm going to turn the volume up a little bit and turn the volume up on my computer a little bit. Oh my goodness. Nice. And then let's see how that sinusoidal wave function thingamajig is. Get the thing back. Very different sound, right? Let's make it a higher octave. Oh, so now you've got yourself a 6-voice polyphonic synthesizer, and do I need to say more to you than rock out, man? Oh, what am who's not working here? There we go. I will see you in the next tutorial.